Hi everyone, welcome back to my YouTube channel. My name is Imad and today we will be talking about features and feature engineering. This is an introductory video, very basic if you're just getting started in the field of machine learning and you want to know what features are and what feature engineering means. This is the video for you. In this we will just take a look at how you define features and what the process of feature engineering means in the context of building a machine learning model or a machine learning system. So let's get started. To start off, I will present a few statements to you that you might have heard while reading online blogs or talking to some of the people who are working actively and trying to build models. So statements like, what features did you use while trying to build your model? Or the features you used did not have a lot of predictive power. Or statements like, these are very few features, you need to add more. These are a lot of features, you need to reduce them. So everywhere you see there's a lot of talk of features, and people, especially while building a machine learning model, and then they ask you about what kind of features you used, how effective are they, how predictive are they, and if you are wondering what this even means, then you've come to the right video to understand what means and what feature engineering means in the context of building a machine learning system. So now let's get started with what is a feature. So before we look at what a feature is, I think what's important to understand is the entire process that or entire process of building a machine learning model is dependent at its core on something we call as data. And data at its core is the observation of real world around us. So whatever you see around you, you see people, you see machines, you see systems, you see logs, all of these things are in a way what we call data, right? So data at its core is how you observe the world around you and then store that in a format that could be reused and reread. Features is essentially a numeric representation of the raw data that you observe around you. So it's a way of representing these observations that could be useful to perform further tasks. And that is it, right? So features are derived in a way from data, but they are a way of storing your data. I mean, you store your data, but they're a way of perhaps transforming or changing your data that is numeric and that could be useful to perform further tasks. So I have an example for you here, and this will hopefully make you understand how what is features in the context of building this machine learning systems, right? So you have a real world activity here, and perhaps there's a doctor or a nurse taking care of a patient and figuring out different vital information about them, and that is stored in a numeric format that could be useful to do a lot of further analysis or prediction that you see on the right. So on the left is the process, the real world activity of a doctor monitoring a patient, and on the right you see different columns or different features. And when I say features, each of these individual columns, like the patient gender, oxygen level, pulse rate, all of them could be considered as individual features. And based on, and each of the row that you see are different patients. What's interesting also to note here is that all these values are numeric. So the numeric representation of raw data is called features, as we saw was the definition earlier, right? So we have a real world activity, we store the data, and then we have features. So that is all about features, right? Features is essentially storing data in a numeric format. What is feature engineering? So as you might have probably guessed, engineering features or creating features is what is called feature engineering. And to put it into context, I would like to take you through this diagram where you see where feature engineering fits while building a machine learning system, right? So if you look at this diagram, this is a very popular diagram on the internet. You have different data sources. There's source 1, source 2, so on up to source n. And all of these data sources are in different formats with different data types with, say, different amount of information. All of this gets stored as raw data when you're trying to model a certain process. And that raw data is then transformed into features, and these features are fed into your modeling process, and then you get your insights or your predictions. So that is the entire end-to-end pipeline, and feature engineering sits right in the place between your raw data and the features. So essentially the process of converting your raw data into features is called feature engineering, and you do that in a multitude of ways. So here is here it says clean and transform, but there are a lot of different things that you do to be able to create those features that are useful for a task that you want to perform. So when you're modeling, you're essentially trying to perform a certain task. You're not modeling without an inherent goal in your mind, right? So you have a certain task you want to perform, and modeling is done with respect to that. So feature engineering is also in a way dependent on the task at hand. It's also dependent on the model you're going to choose and the data you have. So these three things are what contribute to your feature engineering. So feature engineering is not like an independent activity like some of the people around might think, but it is also dependent, like I said, it's dependent on the data you have, it's dependent on the modeling task you have, and the models that you want to subsequently use. So this is the phase, this is an example of how feature engineering is used. It's the process of converting raw data to features. And now let's take a look at the example I was talking about. So earlier we saw this example, but I intentionally omitted one part of the process because I was trying to show you features. But in the real world, you might not directly go from real world activity to features. There might be, and it happens more often than not, that you store the real world activity as data, and then you go through an entire feature engineering process and convert that to features. Like for example, in this case, right? So like I mentioned, the example is about a certain process that the doctor or the nurse is doing, and they might, they of course they will not go ahead and write patient gender as 1 or 0 because it doesn't make sense to them. So they would represent it as M or F, male or female in this case. But for the purpose of our modeling, we need to convert all character and string features into numeric features, and I mean all character and string data into numeric features, and that is where the process of feature engineering comes into play. So this is one very basic kind of feature engineering where you're basically encoding the different categories that you see in patient gender to a representative numeric value. So male is represented as 1, M is represented as 1, and F is represented as 0 in the case of patient gender. So that is what you do in feature engineering. You convert your raw data into numeric values. Feature engineering, yeah, just to summarize, right? So basically, conversion of raw data into a numeric value is feature engineering. Feature engineering is dependent on the data you use, is dependent on the modeling you want to do, the task you have at hand, and the models you select eventually for the task. So that is what I wanted to talk about, give you an introduction to what features are, talk about the process of feature engineering and where feature engineering fits in the entire pipeline, and how data can be converted from raw form into a form that is useful by a machine learning model, and also what does feature engineering depend on. So all of these things is what I wanted to convey in this video. If you like this video, please don't forget to like, share, and subscribe. And yeah, of course, subscribe to my channel because I will be putting out more such videos in the upcoming few weeks and months, hopefully. Until next time, see you around.